Okay, so writing paper is a skill. We talked a little bit about this last week. It's a skill you can learn, and that's part of what we want you in terms of research methods in computer science. The most important research skill I can give you is helping you write good papers, right? Because the rest of it won't matter if you can't get somebody to help you write a good paper. And it's definitely worth learning. The more your papers will be accepted, the more brownie points you'll get, you'll have better ideas. That's actually, to me, the best reason. Hopefully this exercise, in fact, the first exercise in browsing and now this exercise, right? If you find a better way to break up your space, it provides clarity of thought and help identify, here's research opportunities I can work on. As I explain my research to other people, I can put it in a better way. So that will actually help you. So here's what many people think of as the model for how to do a paper. You have an idea, you do some research, you write a paper. Nah, that's not how we do it. Okay? My recommendation is you have an idea, you write the paper, you do the research. Okay? This is actually closer to the scientific method. You have a hypothesis, whoops. You have a hypothesis, and then you go out and test it. And the only difference is when do you write the paper. Okay? My recommendation is as you write the paper and you go out and do the experiments. Now, there'll be some overlap. It's not completely sequential, but you want to be writing the paper and understanding this is what the paper is before you do any experiments. Why? Because if you think about our tetrahedron of science, truth, storytelling, or whatever, there are many stories I can choose to tell related to the same absolute truth. And I can write experiments that prove the same absolute truth, but tell different stories, depending on where I want to go with it. So that's part of what you want to do, is you want to figure out, here is the story I want to tell, and here's the experiments that show that story. Okay? And part of the answer is it depends on where I'm submitting a paper. In my field, if I'm submitting a paper to NIPS, I might do one kind of experiments, and I would have proofs in the paper. And if I was submitting it to CVPR, I might have a very different data set with the same algorithm and no proofs, and spend more time on large-scale experiments because I'm writing the paper from here's how it helps in real-up problems. And if I was going to the winter applications of computer vision conferences way out in the application space, right, I would focus way more on the applications, and I want to make sure my data was more realistic. However, it might be the same core idea, but 3 different venues call for 3 different sets of experiments. Right? And so you start writing the paper, you choose the venue, you figure where you're going, and then you start the experiments. Often as you write the paper, it really helps you crystallize what you don't understand and what you need the experiments to help you prove, to make things go along the process. And often it just helps refine the idea. As you're writing the paper, you start talking about what's the experiment, what's it going to show, what's it going to measure, because that's what you want in your story. And as you do that, it helps you refine what the experiments are. Okay? Now, realistically, that I think is also a little bit naive. Here's the real model, the right model. You do the idea, you do a draft paper, and at this level, you're not worrying about grammar, English, you're just putting together, here's the storyline, here's the core elements of the paper. Here's the related research, and I forgot to mention that when I did the last one. Before you do experiments, you really got to know all the related research because you might have to compare against them, and when you read them, you might recognize, oh, my idea is already done, right? There's no point in doing the experiments if your idea is already done. You got to figure out how to make the idea different enough that you can do this. So that first part of reading the related research paper, doing the related work section is actually really important. Then you do the research and the experiments, right? Then you revise the paper, and very often you iterate because what you thought was going to be the story isn't supported by the experiments, or it is supported by the experiments, but you have a better story now that you've seen the experiments. It gives you some ideas to go someplace else, and so you iterate a couple times. And the advantage of this model is it actually allows you to find the best story in what you have. You had a good story, you did the experiments, and then you might find a better one. You can do that. So, and this really separates this idea of shitty first drafts, which we talked about last week, from the final paper. And it makes it easier to say, I don't care how good this is, right? Many of you will get stuck with writer's block because you don't know how to write it up. Well, the first draft isn't about the actual final paper. It's more like, here's the story of the paper, here's the elements I need to have so I can go do the research. But then your advisor can be looking at that, giving you feedback and having a conversation and not worrying about what's the quality of the writing. If your advisor is one of those people who can't read it until it's ready, well, then this draft is just for you. That's okay. Okay. So it's really important when you go down this path not to be intimidated. Many people incorrectly believe you need to have a fantastic idea before you can write a paper. And many of you will think, well, all these papers I read did. Now, first of all, you've browsed through enough papers. I guarantee every one of you has seen bad papers that have no idea, okay? And yet they were published. So there's hope, okay? But realistically, right, you may be surprised the ideas you think are not good are actually good. As you write a paper, give a talk about any idea, whatever it is, right, no matter how weedy and this you may seem to find it, you're going to get better at telling the story of ideas. And you might actually find the idea has more of a core story than you thought. It might have started as a simple observation, but as you dig into it, the observation might develop into a theory that's actually provable. Or it might be the observation leads to other observations that does so. So don't worry. You really want it to get going, right? As you write the paper, give the talk, no matter how bad it is, you will improve. Even if the only thing you improve is your ability to tell the story, that idea really was crap, it's okay, it's dead, you move on to the next one, right? You will have lots of ideas, okay? Don't worry till you have the best idea you're ever gonna have. But writing is actually a great way to actually develop the idea. As you try and formalize it, I'm sure you've all had this feeling, and I have it very frequently because of my dyslexia and the weird way I view the world, right? There are times when I can't even think of the words to describe what I'm thinking, right? It's just in my head, and I know it's there. It's this vague thing. It's like this, and it's like I don't know what words to describe it. And that's a very common occurrence to me, but it's true for most people. You have this idea, it's in there, you know it's there, you just can't get it out yet. As you write, you will get the idea out and you'll make it better. And very often, it turns out to be more interesting and challenging as an idea than it first seemed. Sometimes they really are trivial. The biggest problem is not that the idea is not interesting, it's that it's already been done. Okay, so you might have been extremely creative in what we call the personal creative space. To you, this was a completely new idea. Unfortunately, to the world, it's been well known for a while, but that doesn't matter, right? If you develop the insights that let you effectively do something that a great person did 20 years ago, or even last year, right? That's actually showing you're being creative. Now, if you read their paper and you forgot about it, and then one day you recreate it, it's like, that was in there. But most of the time, that's showing your creativity. You're just not yet at the forefront, so you got to get in front of everybody, and then you'll still be doing it. So you got to figure out what's the purpose of your paper, okay? Now, many of you have some reasons to try and publish, okay? It's not really to impress others, to gain recognition, to get promoted. That's okay, but that's not really why you want to write a paper, right? You're really writing a paper for what reason? To graduate. Well, so that is unfortunately a truism. You need one to graduate, so you're going to have to get there. But why are we doing that? Why do we make you write papers? What is the real goal of writing a paper? To be a teacher? No. To communicate your ideas, right? You're really going down this path. You're getting a PhD. A PhD is a degree about research. And really, good papers and good talks are a fundamental part of research excellence. It's about us teaching you this is how you do research. We want you to really understand that, and that's part of it. And it really is about communicating ideas. Your goal when you write a paper is to infect the mind of your reader, ideally like a virus, okay? Because it's like a virus because what you want is the ideas now in their head, and they're going to talk about this idea with two other people, and now they're infected with your idea virus, and then they're going to talk about it with two people, and pretty soon everyone's blonde. I mean, that's a commercial, but no, it'll just keep growing until your idea's out there, right? That's why we want it to be like a virus. You want it to spread, right? If you have to force feed every person to get the idea down their throat, you're not going to get your idea very far. But if your idea is so good that anyone who sees it wants to give it to someone else, then your idea will grow, right? And literally, we're trying to design them so that other people will share them without your input, right? You want people who cite your paper because they saw somebody else's discussion of it that was so exciting, they had to go read it themselves, and that's where it's going to go, okay? The ideas are far more durable than your program if you can actually get a good job, do a good job with your papers. And ideas are one of the few things which are not diluted by their use. If you have an idea and I have an idea and we each share them, we now each have 2 ideas, right? It's not like when I give up my idea, I lose something, right? Everybody I give my idea to, the more people I give my idea to, the more value my idea has. So they're literally worthless if you keep them to yourselves. You've got to get them out there. And unfortunately for you, you don't get to give the same idea out too many times before people start saying, oh, that's the same idea you had over there. You know, what can you give you credit for it? So you want to put that out there and give it a chance to really grow. Okay, so the idea. An idea is a reusable insight useful for the reader. Now notice, I didn't actually talk about this from a research point of view. This is true of a survey paper. This is why I'm trying to push you to categorize stuff, right? A reusable insight that's useful to the reader of categorization is something they can look at and they can break down the world. If your idea affects the way they view their field for the next 8 to 10 years, you have had a profound impact on that student, on the way they view the world, on the way the world develops. And whether or not they cite you all the time, you are having that effect. Your idea is spreading. Okay, so you got to figure out what your idea is, because it's almost assured that if you don't know what your idea is, you're probably not going to communicate it very well. So you got to figure out what it is. And once you figured out what it is, make sure the reader is in no doubt about what the idea is. Right? You've probably all read papers and you're not sure what the idea is. But if you read a paper that says, the main idea of this paper is, and then a sentence, you know what they think it is. The main contributions of this paper are, right? And a bulleted list of items, right? That should be in the introduction of your paper. Now, you might not be that explicit, right? So you could start with, in this section, we present the main contributions of this paper, right? Right. The main novelty of this survey is our categorization, which allows us to place these recent papers in the context of whatever, right? Many papers actually have good ideas, and they don't distill them. I went through a culture at Columbia where we had some scientists who felt we shouldn't tell the reader what to conclude. It took me a long time to unlearn that lesson. You should tell the reader what to conclude. They may conclude some other stuff, and you should support what you want the reader to conclude. But it's actually a good idea to tell the reader what you think they should conclude. They can disagree with you, but it shouldn't be up to them to draw the right inference from your paper. That's just too much effort for the reader's part. Okay. I like to think your paper should have one ping, one simple idea. You can have a few embellishments, but there should be one really clear, crisp idea. When they're done this paper, they know here is the core idea. Okay? If you have 3 ideas, you may be tempted to want to pack them into one paper and say, oh, look at the value you're getting. There's 3 ideas in this paper. And if you're allowed to write a 60-page paper, that's okay. But if you're writing a 10-page paper, 1 idea per paper. If you got 3 ideas, 3 papers, please. Right? Because you just muddle them together. It is too hard to get too many different ideas in one paper. And I suffer this malady myself. I regularly get my papers rejected, and we had too many things in them. We took our first paper on OpenSet after it was rejected multiple times, and it became 3 papers, 3 15-page papers before we got them accepted. And we had to get them accepted one after the other, because it was just too complicated to put together in one paper and get everyone to understand it and feel comfortable with it and have experiments that showed it and whatever, right? Break your ideas. So if you have multiple ideas and you can delineate them. Now, you want to be a little careful about the LPU, the least publishable unit. Your goal is not to figure out how can I divide this idea into 17 little pieces and publish it 17 times, right? It might be 3 or 4, probably not 17. So many of my students have these things in their thesis called chapters. And I sort of expect this paper is chapter, so there's the intro, the related work section, which might be the survey paper, and then there's chapter 3, that's a paper, chapter 4, that's a paper, chapter 5, that's a paper, chapter 6, that's a paper, and then we call it a thesis, right? So especially if it's the same theme, right? If you think I can pack all 3 of these in one paper, then you can pack all 3 of them into one thesis, right? If you can't do that, then they didn't belong in a paper together. And there are theses that are really hard to connect. My personal PhD thesis, no committee member, they discussed it among themselves. no committee member read more than 2/3 of it, because there was a part that was very, very extremely high dimensional mathematics, a part that was computer vision, and a part that was psychology experiment. The vision guy read the psychology experiments. The math guys read the math and the vision because it had some math, but no one read it all, right? So that's not an ideal thesis. You really want a thesis that tells a coherent story. One of my students, Ethan Rudd, who graduated a year and a half ago, right? He had 15 to 17 papers, right? Only five of them were in his thesis. The rest were just simply things he had done that didn't show up in his thesis, right? You make a coherent story out of stuff. You don't have to have it all in there. Okay. So if you have lots of ideas, write lots of papers. Okay, so the purpose of your paper is really never to describe the whiz-bang system, right? That's not your goal, right? Your goal is to really simply get them to have some reusable ideas, not here is the state of something I did, right? This is not art history where you say, here's a description of a painting and here's how I interpret it, right? This is knowledge you want to give them, so you want to put it together. Okay. So what does your paper look like? So you're going to start your paper with this idea. We'll get to the formal structure in a second, but you want to have the intro, which is really describing, here's a problem. See, it's an interesting and important problem. It's a really big problem. Here's the more unsolved version of this problem in our space. We're doing the funnel coming in. Here's my idea. That's the core of the paper. Here's how my idea works, details, data, and then it's going to compare to other people's, and then we're going to come out to a conclusion, right? So this is still in line with what we talked about last week in terms of the story and stuff, but now we have to put it into pragmatic terms. What are the sections you write in a paper? So a pretty standard conference paper would have title and abstract and introduction, the problem, my idea or my approach or the method, something like that, details, the experiment or something like that, related work, conclusion, and future work. Does anyone see anything different in this layout than what you're used to? You've now gone through lots of papers. Bless you. Yeah, there's no acknowledgement, but I'm actually talking about the order of these sections. This is intentionally different from what you're used to seeing. Yeah. So we'll come back to why this is, and I don't always do this because you have to balance getting this in with what your community is used to. I've actually had papers where I put them in this order and people complained about the related work being at the end. They are so used to it being in this place, that's where they look for it, they get annoyed. One of the reviewers actually said there was no related work because it wasn't in the section after introduction, right? And they clearly didn't read to the section that was called related work, which was just before the conclusion. So you got to balance if you can get away with this or not. But I'll talk about why this is actually a better direction. So the abstract. I actually generally write the abstract first and last, but I wouldn't call what I write the first time the abstract. I write the abstract last. After the paper's done, I go back and write the abstract. When I first write it, I look at that to sort of say, here's what I think the paper's going to be about and the story it's going to tell. And then I ignore it pretty heavily. And then I come back and finally write it. And there's definitely been papers where I don't even write the abstract. I just start with the intro because the abstract's the shortened version, so why take the time to make it sort of short? If I have a pretty good idea what the story is, I just write the introduction, write the paper, do the experiments, rewrite the paper, and then write the abstract. And this guarantees that the abstract is consistent with the paper. There's actually very little more annoying to a reader than having an abstract that talks about things that aren't in the paper. That lack of connection is bad. So in the abstract, this is often used by people to decide, as you found when you're doing your fast browse, right? The abstract dominates. Title and abstract, like if that didn't catch your eye, did you go on? No, that was it, right? So you gotta make this interesting. So you gotta say what's the problem, why you have an interesting solution to a problem, what your solution achieves, and what might follow from the solution. What are the implications? What does this mean? Right? You can have some other things, but those four things should always be somewhere in the abstract. If you don't hit those four things, your abstract's not going to sell. You might need to talk about data and paper, comparisons. You might put in some phrases like state of the art and whatever, but all of those are nice to have. These four things you really have to have.
Some people believe that abstracts are the most important part of the paper. Is that right or not?
It depends on how you measure important, but yes, right? In terms of writing, I may spend longer on an abstract than I do on the related work section, right? Because you got to, so especially when you have a very tight constraint on the abstract, but it's hard to tell the right story and keep it very focused. Most of the time, it's not that hard, but sometimes it's really hard to make that story really good. So we might spend an hour on that much text, right? And 45 minutes to half an hour on a page of related work, because the related work is, well, part of it is also because if you've done lots of papers in the area, you have paragraphs about related work you get to reuse. So if you're reusing parts of the paper, then it's very fast, but you can never reuse the abstract. It's always new to this paper. So those 4 sentences, if you actually think about what this talk has had in it, right? The abstract might be that many papers are badly written and hard to understand. It's a pity because good ideas may go unappreciated. Following simple guidelines can dramatically improve the quality of your papers. Your work will be used more, and the feedback you get from others will improve your research. Those are actually the same 4 sentences. State the problem, state why it's an interesting problem, what your solution achieves, and what follows from your solution. Go back and see those same 4 things, right? It's not obvious. I'm not saying the problem we address is, right? That's telegraphing what the problem is, right? You can simply state the problem. Many papers are badly written and hard to understand. That's a statement of the problem, right? It's a pity because their good ideas may go unappreciated. Why is it an important problem? Because the ideas are dying in those badly written papers, and so on. So you go through this, okay? So 4 sentences minimum, and then you can embellish it if you have room for other things. The introduction to your paper, you really get in your structure 1 page. Sometimes, depending on the format, you can get a page and a half and get away with it, but really, you should try and get 1 page. Now, that's often really annoying because many papers have taken up half the page at the top, right? So, like, they have the title and the authors and the abstract, and you can't count that first page as a page, right? You don't have to finish on the first page of a 2-column conference paper that took up half the space, but you really don't want to go past page 2. No matter where your intro is, it shouldn't go past page 2. If it's longer than that, shorten it. Why? Because if it's longer than that, people aren't going to finish it. They're going to go on to the second page, and they're going to say, what? It's still not done? I'm done. Okay? So describe your problem, state your contributions, and really, that's all. Don't go into... So it's a tricky situation. Sometimes people want to put related work in the intro. Okay? There's a reason we have a section called related work. It doesn't all belong in the intro. The only time to put related work in the intro is when you're going to skip the related work section completely. Then you can have a longer intro that puts your work in context, and maybe it still shouldn't be more than the first page and a second page. And most of the time when I do a 2-page intro, it's because I have this giant figure, which I'll talk about. And when your figure is half a page, it's really hard to fit everything on 1 page, right? You have a title, abstract, and a figure, and that's it. You got to have some text. But, So we'll talk about figure. I don't know if we'll get to figure placement today, but you should place the figure where it is best for your story. Okay? So normally in LaTeX, you actually want to put the reference to the figure before your text. You want to put the figure before your text references it, because LaTeX will float figures forward into the file, but not backwards. It can never put the figure before it's read the figure. And once it's started on a page, so if LaTeX filling out this page and these columns, right, if the figure is read when it's already formatted this part of the page, it can't float it to the top of this, even if here is where I mention it, right? But if I put the LaTeX up here, then it can actually put it at the top of the figure. There'll be some text, and then there'll be fig 2 over here, right? So you often push it up a little into the document so it can float it down, if that was your question. Okay. So anyhow, so you want to keep it to 1 page. You want to keep an example. My recommendation is the intro should always have an example the audience can relate to. It might not, I mean, this is not a very meaningful example, but you know, it's CS code or whatever. But if you think about success and the acronym we talked about last time, right, you want something that is concrete, that the audience, the reader, can tie into. So if they get something in the intro that is concrete, they've bought into it. Now they can sort of follow. It's concrete. They can sort of go along with it. And hopefully it's simple. Okay? It may not be the best example, but it's a simple, concrete example. Okay, and if you can make it so that it's actually unexpected, you've got through the suck part of success. Okay, write your contributions, and I'll right here. Right, you should have something at the bottom of your right. In this paper, we put our choice on a firmer basis, and then you share your conclusions. My recommendation: it looks like it wastes space, and it actually does increase the amount of space your paper takes up. But your contributions should be a bulleted list in your paper, not a paragraph with numbers 1, 2, and 3 hidden inside of it. It should be a bulleted list. People who are reviewing are so tuned to this, they go looking for that list. Where are the contributions? If they don't see it, maybe there aren't any. Okay, so you want those contributions, but my recommendation is, in fact, when you're writing, you write your contributions early, maybe first, maybe in your abstract, right? You're saying, here is what this paper is going to contribute. Once you've stated those, then go back and write the rest of the introduction. So the introduction is a story that starts big and gets to the conclusions are what you're really adding. And it supports that storyline. It talks about the right characters, the development, whatever risks, so that it becomes interesting. And then you really want this to be the point where the reader says, gosh, if they can really deliver on that, this is going to be exciting. I better read this whole paper, right? Because that is what you're trying to get them to do. You want them to move from scanning the paper to now it's a critical creative read, right? That's a time commitment adjustment. You want to get them to buy in, okay? Don't leave them wondering during the scan, is this paper important enough? That should be really easy. They're scanning through the paper. This says I have to read the paper, okay? Contributions, when you say them, this is tricky because lots of people don't have contributions. They have a description of what the paper has. And you can have one, maybe two of those, but you want real contributions. Contributions need to be something that's refutable, okay? We describe the whiz-waz system. It's really cool. Sorry? That's not a contribution, right? We give the syntax and semantics of a language that supports concurrent processes, section 3, its innovative features are, whatever, right? Now you've said something they can verify. It's actually useful sometimes to actually give them a section number. Okay, I said last time, right? You don't want to have a table of contents as a paragraph, but having forward references to the sections that show your contributions is perfectly fine. Because what you're really saying is, if this is the contribution you need, go to section 3. If this is the contribution you need, go to section 4. You don't present it as, in section 4 we do this. You say, here's the contribution, see section whatever for details. Okay? We study its properties, right? No. We prove the type system just is sound and the type checking is decidable, right? You're going to say, here's what we actually do, not that we study its properties. It's true you study its properties, but that doesn't help the reader understand if those properties are worth looking at. We have used the whiz-waz system in practice, right? You know, we built the system, we implemented it with a text editor. The version is half the length of the Java version. So we actually did it, we experimented with 500 subjects, whatever. Get into how you actually validated that it was useful, not that we have used it. Okay, so those would be conclusions. Okay, and no matter what you did, don't have the rest of this paper is structured as follows. That is a sign you did not have enough content to fill the paper. Remove it and add a figure. You don't have to write any more words. You can just add a good figure, and that'll actually make up for all the space, and probably more. Okay. As I said, use forward references in the introduction, in your contributions that can go forward, but you don't have to know it. You know what? People have read these research papers so often, they know the order they're going to be in. As I said, I've tried this. Better to not put the related work here and put it at the bottom. But be careful. Talk to your advisor. Look at the papers in the venue you're looking at. If you can find no papers that put related work last, it's probably too dangerous for that field for you to do this among your early papers. You can try it later after you get some experience, and it won't matter so much that you get rejected because people say there's no comparison to related work. Okay? And absolutely only do that in a place where you have a chance to give author feedback and rebut the reviewers. So when the reviewers say there's no related work, you can say, yes, there was. It was right here. It's page 3, you know, whatever. And the other reviewers might get them to change their mind. If you don't have that, you just take too many risks. Okay, so why do you think I don't want related work after introduction, despite the fact that you see it so often? They might dismiss the paper too early, right? They were excited. They were reading about your problem and your idea, and now it's like, oh, look, here's a literature search. How many of you, when you're doing your creative reads, skipped the related work and went right to the next section? Most of you, okay? So why, if that's what we're going to do, are we going to put this related work between your reader and your idea, right? It's actually, let them buy into your idea, get into it, and then you can have related work later. It actually makes it easier to explain. It's a struggle sometimes writing the related work sections to say, here's this paper, and here's how it's different from ours, but I haven't told you what ours is yet. I mean, it's really hard to make that comparison. It's much easier to do that after you've introduced all of your stuff, and then you can relate it much more easily. So it's nice, but in most of our fields, in my fields, it's hard, right? You can do this at NIPS. You can't do it at CVPR. It's getting to the point where you might be able to, but it's tough. And then like ICML, never. Yeah, when I tried this for ICML and for one of the NIPS papers where we've done it, you have in the intro, like you take the one or two most related pieces of work and you include them in the intro, right? This problem was introduced by these people. That's really the way, because they did introduce the problem, we're just going to make a better solution, right? And we discuss other related stuffs in section whatever, right? The important is that we significantly advance beyond the accuracy of their solution, whatever. So you can put a few references in the intro and a forward reference, then it's okay. But that still presumes people read it, right? Okay, so as I said, the reader really doesn't understand your problem yet. Depends on how much you put in the intro. So your carefully trimmed descriptions of the various technical trade-offs is largely incomprehensible. They can't really understand your related work section. Describing the alternatives between the reader and gets between the reader and your idea, and in fact, they might actually think your idea is so derivative because you had a short description and you now have a hard time differentiating it. You risk the risk that they think your idea is not new. And then finally, as I said, readers skip it and come back later anyhow, right? So you might as well just put it later. But we'll see. Okay, so the problem, right? Presenting the idea. It's really important, these three together, the problem, the approach, the details. And whether or not you call it the approach, the methods, whatever, those are really the core of the paper. Okay, when you're presenting the idea, and so the introduction introduced the problem. Very often when you have a section called the problem, it's more like formalizing the problem, right? The introduction was a vague, very broad view of it. Now I'm going to make it very formal. This is true, especially in our fields where we have machine learning and vision stuff, where we try and be more precise about here's what we're assuming about the world, here's the inputs, here's what we're going to do. It's true in some cyber places where you assume here's the formal models of attack and whatever else is going to go along with it. So you want to choose what that is. And be careful when you're presenting the idea not to get really deep into the terminology of the subfield as you view it, right? So, considering a bifurcated semi-lattice D over a hypermodulated signature S proposed, whatever, okay, yeah, it might sound impressive, and there might be 3 people in the world who are impressed because that's exactly what the way to describe the problem. You got to get them into it gently, right? You got to have, here's the sort of general introduction, and here's how you have the motivation for the problem, which might be in the intro. Now you're going to sort of formalize it, describe the formality informally, and then have the formal stuff. You got to convey what the idea is before you jump into the mathematical descriptions. How many of you, when you read a paragraph like this, skipped over it and just went on? Okay, right? So think about that and remember how you were as a young reader. If this is something you would have skipped, don't write it that way, right? Because you're just inviting the readers to do what you did as well. Skip over it. It's funny, after you get deep in the field, this is what you believe, this is the way you, like, those people sounded so smart, I want to be that way. Not really. They were so smart you skipped their work. That's not really that smart. You want to pull them in. Okay, my recommendation is you explain it as if you were speaking to someone using a whiteboard. Here's the main ideas. Here's a couple of equations to go along with it. Here's a drawing to help explain what's going on. Tell your story that way, especially in your first drafts, right? You can always formalize it a little bit later, but it's hard to get that good flow. This is why I actually do recommend you try and write your paper by talking to it, right? Taking dictation, talking to a microphone, whatever. If you're really comfortable using face your camera and actually whiteboard it out and then turn that into your story to make it work. Once you have that story part, it's okay. Conveying the intuition is the primary, not the secondary goal of your paper. People are not likely, unless they're this weird subtype, to remember the math and the formalisms. They are likely to remember the intuition. And even if they are the subtype that can remember all the math, math is rarely infectious, right? It's not a virus that spreads easily from person to person. You normally have to shove it down students' throat to get it to go, right? You want something that's intuitive, so easy, and so flows off so freely that it spreads quickly among people. That's what you want to get across. Once they have the intuition, he or she can follow the details, but very rarely vice versa. Very rarely can people read the math and say, oh, now I get the idea, right? If you can see the equations and visualize the graph in your head, you're among a very few special people that can do math that way. So even if you skip the details, she'll still take away something valuable from the intuition, which is by far the most thing you want to get out of the paper. So worry about that story from an intuition point of view. And that's why, despite how corny some of the stuff I talked about last week of a character and a struggle and risks and whatever, right? That stuff is what humans remember. They're good at remembering those kinds of story elements put together in the right way. And if you can get that across, your paper will be remembered. Okay? Remember, you're putting the reader first. This is not about your journey to discovery. This is not the 23 things we tried that didn't work, and then finally we got this to work. You may eventually get to tell that story, but not in this paper. This is also why it's very deceiving when you read papers, because it's not how the research was done. No one said, wow, I have this great proof of this idea. Now let's figure out how to implement it and get some intuition and work. Right? Intuition probably came first. Implementation may or may not have come second, but no one thinks it in terms of the proof first, and then a few do, but most people do. Most research is not done the way you read the paper. And you shouldn't write the paper in the way you did the research either. You shouldn't say, well, no one does it that way, I'm going to do it. I've been down this path. I had my first grant proposal rejected for exactly that reason, where I said, here's the 12 problems I'm going to attack. Here's my general way I'm going to do the research. And they're like, no. Choose one, tell us a good story about it, and then come back for funding, because we're not going to do this random approach, even though it's what people really do. Okay, so the main payload of your paper, you're going to introduce the problem, your ideas using examples. Only then present the general case. So a good example, it might be 4 or 5 lines, it might be a figure and some text, whatever. You've got to get the reader to understand a simple version of your problem with an example, or they won't understand your problem. Okay? You might worry that, oh, that's too simple, it's not quite as nuanced as my problem. That's okay, that's why they can understand it. Then you can add the nuances later. So you want a really simple example. When we get to the figures, we'll talk about that, right? So you want something that's really simple. If you can give an example, for those dealing with code and whatever, you can give some code examples that are small and done right away. Here's it without optimization. Here's it with optimization. It saves this kind of stuff, right? It doesn't matter that it's not a big example, and the savings of 10% on 4 lines of code is like, so what, right? Then you can always make the example more interesting by saying, well, now imagine those 4 lines of code are in a loop that's executed 1 billion times. 10% times 1 billion now matters, right? So you got to put it in the right context. But your paper has to have the details, the evidence, the experimental section if you're doing experiments, the theory and proof if you're doing a theory paper. There's some section that has lots of details. So in this section, you're going to introduce your claims, and then you're going to provide the evidence to support each of those claims. Good structure would actually be so that I can actually see, here's a claim, here's the data to go with it. Okay? It is tantalizing sometimes to say, okay, here's all the experimental data, and then let's discuss all of it. It is actually better for the reader if you say, here's an experiment, here's what we can conclude from this. Here's another experiment, here's what we can conclude from this. Right? Then he or she gets to read them in pieces and doesn't have to remember 4 tables, right, of data before you start the discussion. Put them separately. So it's good to often have in that section subsections. You describe, we're going to go through 4 experiments. Here are our 4 main claims. These are described in these sections. And put them together that way. Now, in the survey paper, by the way, everything I've said so far all applies to your survey paper, right? Nothing I said is about just research papers. The details are where that's a little bit weird. In the details for your survey paper, that's where you're going to take your taxonomy, and now, right, you're going to actually start putting the papers. So you'll have subsections based on the elements in your taxonomy, right? Whatever it is, if it's a matrix, you'll have some discussion of one dimension of the matrix, then some discussion of another dimension, then the other dimension. If it's a tree, you'll describe nodes in the trees. You'll have had a figure, which will be in the intro or the approach, where you've said, here's the big layout. So you've already named those things. And you can even put section numbers in your drawing. And now you're going to get into those sections and go through each of those. So the idea there is to support the claims that there's some relationship among these that is sort of interesting. So the evidence can be analysis is a comparison, which is what you get for papers. Here's the analysis of these papers, here's the comparison, and what's common. Yes?
Is there any way to verify the experiment? Because I found some papers that I tried to verify the experiment and it wasn't running.
So how do you verify their experiments? I would, if I had to hazard a guess, I would say less than 10% of computer science experiments could ever be verified. So if you put enough effort into them, you could probably get to 10%. Some of the others depended on things they never told you, right? And if they didn't tell you and they actually matter, you can't know it, right? So that's tough. And maybe it's 25, 30%. It's actually getting much better in computer science because more and more people are saying, here's a GitHub with the code and the data. But my students have been working for the last month and a half on replicating somebody's experiments that gave us a GitHub repository and their code and their data, and we still couldn't replicate their papers because the code in GitHub wasn't exactly what was used in the paper. There was missing one command line argument on one place, but how do we know what they did in the paper, right? So, when there's 14 command line arguments you can place in, 2 to the 14th or whatever, 14 factorials, like, it's a ridiculous space to search. We eventually got the author to answer, and now we can replicate his experiment. So the answer is, the only way to really replicate an experiment, even with the author's code, is probably with the author's help. You write to them and you ask them questions, okay? And if they don't answer, then in your paper, you can say, we could not replicate these results. That's the best you can do, right? And you can even tell the authors, right? If we can't, we can't get these to replicate, we'll just say that in our paper, and that sometimes get people to want to reply. The other is sometimes there are other papers that have sort of replicated the results. They normally don't get exactly what was in the paper, right? And sometimes getting exactly in the paper is very hard. We've had our own experiments we can't replicate because we forgot to save the random numbers that go into building the neural networks, right? Because when you build networks, they're randomly initialized. And if you don't use the right random seed, you don't get the same results. Now, you get comparable results, but never exactly the same results, right? So it's a tricky thing. So we got a little bit off. So the structure, as I said, if you really can try and push your related work to the end, that's where it works better. So many people think the related work section is to make my work look good and I have to make other people's work look bad, okay? I got to show I'm better than them. Therefore, I have to make them look bad. That's not what you want to do. Whoops. The truth is, credit is not like money. Giving credit to others does not diminish the credit you get from your paper. In fact, saying they did a good job and I made it even better is way more interesting than saying they did a crappy job and I did a slightly less crappy job, right? Which is the way it will come across. If they did a bad job, you have to then have, if you're saying they did a bad job and they have like 40% performance and you get 48, you must do a bad job too, right? If they got 10 and you got 90, then you can beat them up a little bit. But in general, just give them, these people have helped. They gave you some ideas to get in the way that helps you go through the work, right? Talk about any technical stuff, but don't beat them up. Why not? Besides the fact that it's just not good karma, remember, they might be your reviewers, right? So anything you say bad about them might not sit with them as a reviewer. And it's tough when you're a reviewer and you get people, I dealt with this in a recent review, where they said, we didn't even cite this paper because it was so bad, right? It's like, okay, well, or sorry, they cited the paper, but we didn't even discuss it because it was so bad. They just cited it, and it's like, there's no reference going on to it. Okay, in the paper, right, don't say things you don't believe, right? So, like, if the paper was interesting, you can say in their interesting paper, right? If they said, right, in this paper, they had this crappy security idea, right? Don't present it that way. You can turn around and make it pretty positive. Also, it's tricky. You want to acknowledge the weaknesses in your approach. This is actually common in my field. Papers that don't talk at all about their weaknesses are often beat up by reviewers because now you're going to make me as a reviewer think hard about what is your weakness. So you should think about, here is my biggest weakness, and see it's not that bad. if you can forgive me for not being able to solve these 5 examples, and there are 5 examples that I fail on, maybe I can forgive your, if you forgive me for that, my paper's okay. But if you don't show me any failures and your system's only at 68% accurate, then do I know that you're failing on hard things, or maybe they're all easy things and it's whatever. So, so as I said, failing to cite credit can kill your paper. If you imply an idea is yours and not theirs, that's it. You're done. So either you don't know it's an old idea, that's bad, or you do know and you're pretending it's yours, and that's really bad, right? So it's really important that your literature search finds the most related papers, okay? And they may not describe it in the same terms you do, which is part of why we did the browsing exercise, because you'll quickly figure out, here is something. At a minimum, one of the things you should do, take all the papers you're citing that are more than a year old and look quickly through the papers that cite them to say, could one of these people, because if you're citing them because they're related to your problem, hopefully somebody else who's also solving something related to your problem also looked at those papers, right? That gives you a quick reassurance that maybe I just didn't do a bad keyword search. Just browse through those extra papers and make sure they're there. Okay, so conclusions and future work. As I said, whether or not you're going to have future work, be brief, be a conclusion, not a summary. You don't explicitly have to talk about future work. Some risk is that if you do, the reviewers might say, well, if the paper had actually done that, I'd be excited about it, but now they didn't, right? So if you're going to talk about future work, make sure you limit the process about why you didn't get there, right? We did 4,000 hours of experiments. Future work is going to take even more, right? Something like that, so you can limit it somehow. So I already covered a bunch of this stuff because I'm doing this talk out of order, right? So start early. Hastily written papers get rejected. So you want to do many iterations, get them going, use GitHub, collaborate. Reading your papers by as many friendly guinea pigs as possible. I think this was all in my first couple of talks. Yeah, nothing there. So listening to reviewers. It's really important when you get this feedback to treat them with respect. If you submit a paper to a conference and the paper is rejected, those reviews are really a blueprint to what you need to do better, okay? It is sometimes tough and it's almost like a personal insult, okay? It's really, really, really important that you step back and say, this is my failure, or this is our failure for our team. We failed to communicate it so these reviewers got it. How do we fix our communication problem so they get it? Okay, it's tempting to want to say reviewer 2 is an idiot. There's actually a whole website about reviewer 2. They're idiots. They don't get the paper. It won't help you very much. Now, if the other reviewer 1 and 3 said this is a great paper, reviewer 2 is an idiot, you can take some solace and sort of dismiss it. But otherwise, there is something about how your paper communicated that didn't get to reviewer 2 to understand. They might have been rushed. They might not speak English as their first language. They might not really understand your field. But that's still partially your problem because your job is to communicate to that broader audience. So if you do take the criticisms positively, we're going to do some in this class. Don't respond, you stupid person. I meant to say X. Fix the paper so that X is apparent. Okay? You will never win an argument with a reviewer by insulting them. Just isn't going to happen, right? They're anonymous. They're on the other side of the table. Thank them for giving you help, giving you feedback. You may or may not agree with them, but don't actively disagree with them unless the other reviewers are already on your side, right? So you can say, as reviewer 2 and 3 pointed out, this section is mathematically correct, right? Reviewer 2 didn't explain. Can you please explain why you think it's not, right? Because the reviewers say this is just wrong, right? And they don't explain it. So ask them to go into it. Language and style and some other very basic stuff. Submit by the deadline. Know what the deadline is. In what time zone, right? When they say Friday, what the heck does that mean? Friday 9 a.m., Friday 5 p.m., 5 p.m. in whose time zone? London's, ours, Hawaii's, right? There's normally, they're getting better and better at this, but you want to make sure you know those answers. My recommendation is you upload a pretty good draft, which you should have at least 5 hours before the deadline, upload it so that if something terrible happens and they choose not to give you an extension, or you misunderstood something and you could swear it said Pacific Standard Time, right, or Pacific Daylight Time, and it actually said, right, GMT. Well, actually, you're off by more than 7 hours, so you're in trouble. But if it said, East Coast time or whatever, just upload one early. You will be surprised at the last couple of minutes for a large conference or a large venue, ICSI, right? Their servers grind to a halt when 4,000 papers are being submitted in the last hour. And it's not actually 4,000 papers. It's probably more like 20,000 papers. Because each of those 4,000 authors probably uploads a version, finds a couple more typos, uploads another version, finds a couple more typos, uploads another version, right? And you're going to go through the same process. So upload one early, make sure it's in there, then you can iterate through it as things go on. Keep to whatever stuff they tell you. Whatever the margins are, don't use 6-point font. If they tell you, right, they'll give you a style guide. I'm actually well known in my lab for pushing the limits. I will read the style guide, and it doesn't say anything about the spacing between the header and the first paragraph. Then I feel I can adjust that a little bit. Others say, like AAAI, right, do not use the VSpace command in LaTeX anywhere. Right? So they're very clear about what you can't do. Then I don't do it. Always use a spelling and grammar checker. If your advisor touches the paper, check it. Do not believe your advisor is better than you because, your advisor could, the world just gave them melons, right, as opposed to lemons, right? So, go through that. You want to give your paper a strong visual structure, okay? You want to make sure how to draw pictures and figures, and we'll talk a little bit about those, right? So a paper should look like a paper. Interestingly enough, in CVPR 2015, I think it was, a group of researchers took all of the papers that were submitted to CVPR or were submitted to archive in this computer vision section of archive within 3 weeks of the CVPR deadline, and we said, those are all the papers being submitted to CVPR, because that largely is what's going to happen. And then they took the papers that were accepted by CVPR, and they turned them into JPEGs that were little less than 1,000 by 800, something like that. Whatever the aspect rate, 8 by 11, right? So I guess it's 1,100 by 800, right? You can't read the paper. It's just little blips, right? So it's much less readable than this, okay? And then they took those papers and they ran them through a training algorithm that took the images and then tried to predict whether or not the paper would be accepted from a thumbnail of every page of the paper. They got 70% accuracy in prediction. Right? Papers that, and lots of the papers were not structured well, were largely going to be rejected. And papers that met the formats and looked like all the other papers were more likely. Now, that might actually just be because the people who know what they're doing know to use the format, and those who don't. But it makes it much easier to figure out what's going to happen with the paper. So care about it. Use the active voice, right? Not that it can be seen, we can see. That's a perfectly good royal we. We ran 34 tests. That's not royal. There's only if we have multiple authors. But my recommendation is get a second author. Then you can use we all you want. Don't have these sort of passive things. If you use Grammarly, Grammarly will yell at you for passive. Now, do you think there's any time you do want to be passive? Tina, when do you want to be passive? When you're trying to be negative or downplay something, it's not quite negative, but you want to make it seem like it's not that important. Yeah, that group got 86% accurate. Okay, yeah, fine, who cares, right? We got 87% accurate, right? So you alternating passive and active can still be there. So it's not like no passive, just be very careful when you're using it. So that's tricky. There's slightly different styles. I like to actually write in the past tense for the experiments were in the past, and it just makes it easier in my head. I don't think of this week as we did last week, right? Oddly enough, when I'm referring to a paper, the paper I'm referring to is in present tense. So this paper shows, not showed, right? Because the paper still shows it, right? So that makes the tensile things more interesting. Use very simple, direct language. The object under study was displaced horizontally, right, as the ball moved sideways, right, or the ball moved along the x-axis if you have a graph or whatever, right? On an annual basis, yearly, right? Keep things as short as you can. There's a few that are idioms in your subfield. Grammarly does not understand your idioms in your field, right? In security, they will look at things you say and it'll make no sense. The word deep networks, it loves to say like underground cables. It's like, I'm sorry, that's not deep networks, but no, it'll go through. So if you remember nothing else, you're going to tell a story. We talked about that last class. You're going to identify your key ideas and make them explicit. Make your contribution to those key ideas very explicit. You're going to use examples and follow the rules of the paper. Those are all really key things. Okay. Now, I've got 10 minutes, so I'm not going to make it through all the figures and drawings, but I want to hit the key things because hopefully you'll think about these. So first of all, figures and drawings should tell your story, right? As I said multiple times already, right? I believe in the comic book version of your paper. Figures and captions should tell the entire story. This is tricky, especially when you get people who won't let you have long captions. There's some journals where say captions can only have 100 characters, right? Figure 4, right? A figure, see the text, right? I don't know. You'll see some of my captions in a couple of examples. So by far, the most important figure in your paper is the first figure, which is either a teaser figure or a visual abstract. And the difference being that a teaser figure hints at something, makes you want to read the paper. A visual abstract actually summarizes the results of the paper. Now, in lots of areas, they call them both teaser figures, but to me, there's actually a distinction between, is my goal that when you read this, you know everything you really need about the paper. So these are some examples from there's actually a link there if you want to talk about how to write a visual abstract. It's a visual summary of the information contained in the abstract. So this paper is talking about 72% of prescribed pills went unused. Right? So they have 70, 100 here, we got some green, some black. Right? You instantly look at this one. That's not a very deep one. That's a pretty bad one in my view, but it conveys it. This one is sort of showing that they had this patients undergoing elective colonoscopy. They were randomized, some were here, when they went through this process. And this group had pastoral heart hernias with no mesh infections. So if you understand what that space is about, you can read through that entire figure and get pretty much, here's what the paper's about. I'm going to decide if I'm going to go on, right? It's more useful than just reading a textual abstract for lots of people. Okay, so I'm going to do through a couple examples of these. So a sample, this is what I call an example teaser figure. This is from one of our papers. This is a simple example. The idea with this kind of teaser is to get the reader to think they understand the idea and why it's valuable. Right? There's no real meaningful data here. It is a simple toy example. In this case, there are like a couple of classes, and then I'm showing the surfaces that are being computed, and we talk about how can it handle these unknown points, and it's trying to get the reader to understand both the problem and a little bit about what our solution is. But there really is no overall set of results. So this is absolutely a teaser figure because it's not everything about the paper. It's really just here's enough to get you to want to keep reading. Okay. And that's useful if you can't come up with a good enough way to describe in that one small figure what's going to happen. Okay. And we do some of those in my papers. I would say more than half our papers have a teaser figure. But the next one is still a little bit of a teaser in the sense that it teases with the results, but it doesn't actually explain how this works, right? So this is sort of showing the 3 competitions in ours, and this is a plot of performance. Okay, in this one figure and this caption. So this figure in the format of this conference, this is from our NIPS paper, right, which is a single column format paper. This is half a page, right? This one figure. On the other hand, if you read this one figure, you know what the core of the paper is about, what we compare it against, and how in this plot here, we are significantly better than the comparisons. These 2 lines, right, you don't even have to see this very much, right? These 2 lines up here are us, and that's the competition. Right? We totally destroyed them. We're so far separated. Putting that plot together, people buy into that paper right away. They get, I need to understand how they do this because this looks like it's very significant. And from this side, they actually get, I mean, I understand what the idea is. It's a simple idea. I can follow through with it. So those are two examples of teaser figures that make the reader want to keep on going, that I believe were effective because those papers were accepted in PAMI and NIPS, and reviewers seem to like the papers. So because of where the time is, I'm not going to actually go through, I'll do next class, some more examples of good and bad figures, but if you're looking for, and I have, I can't find the first two of these, I own them, I don't know where they went, maybe because they happened with what's the next thing. So I have Resonate and Edward's Beautiful Evidence, right? These are books about how to tell good stories with figures, right? So if you want to figure out, like, how do you tell a story with figures, you might actually learn about how to tell a story with figures. So all four of these books are really good versions of this. The library used to have both of the first two, and I had my own copies. I don't know where they are. Resonate and the other, and one other book, Slidology, I have in my office. So if you want to borrow one of these, let me know. I'll actually, since I'm going to be gone, I'm going to put them back in the VAST lab. Does everyone know where the VAST lab is? Engineering 149, like right across from the doors. So if you go in, on the far left is a bookshelf. These will be on the top shelf of that bookshelf. You can just go in and borrow them for a little while if you want to read through them. But this might give you some ideas if you're struggling, like, how do I tell a story? Well, after you've read through 40 or 50 different kinds of stories with figures, you start to get ideas of how to tell that. And it's a very important thing. So next class, I will cover some guidelines and examples for how to do some figures, mostly with examples of what not to do, because those are often the things you'll remember. It's like, oh yeah, that's not what I'm supposed to do. So, okay?
How we can make things.
Tools. Okay, so let me jump to, oh no. So these slides, by the way, are in Blackboard, or whatever the tool is we're using now, Canvas. So here's a list of some tools for drawing. So I can actually tell you, my number one tool for drawing is not on this list, it's PowerPoint. Okay? If you're really good at PowerPoint, you can draw all kinds of stuff in PowerPoint. If you're not, these are all way better tools, and I still use these tools on a regular basis. So the first two, Matplotlib, are, and I guess you should have put MATLAB on that list. I will update the slides, I'll put MATLAB on that list. These are tools for taking data and making graphs out of it. All of them have decent libraries. These are all free tools, and I forgot to put the /expensive version. So I have Inkscape / Adobe Illustrator. Inkscape is free, it runs on any platform, you can download it. It is a vector graphics drawing package. It's way more complicated to learn than, say, GIMP, which is a draw in an image, but it's also more powerful and makes nicer looking graphics. ImageMagick is another library for playing with images. And then there is, I thought I had, yeah, this slide's not properly formatted. There's a couple more tools. They scrolled off the bottom. I forgot to fix it. So I'll update this list of tools. But there's definitely pretty good tools for taking data and converting them to things, and then tools for drawing. But for this week, don't spend any time on tools, right? Hand drawing stuff is where you sketch out your ideas. You know, if you're really good, I can sketch out ideas in PowerPoint faster than I can draw them because my drawing is really bad. Right? I might as well just do it so that people can read it and give me feedback. But you're fine doing hand-drawn drawings for this week's stuff, and then we'll talk more about it next week. Okay?